Okay, so make sure I got... Okay. All right, guys. So, I have opened up a copy of the game that we had when we left it last week, which is why mine says Session 9 at the top. At the end of every session now, I'm just making a copy of the game and numbering it for the following week. So, we've got quite a lot working here. We've got music going on. I'm going to start playing real quick so we can see this. We've got music going on. We've still got a wall that bleeds. We can kill zombies. They can attack us and do damage. And we'll see our damage indicator get more intense as we take more damage. Really should have had her do a lot more damage. And yeah, I really enjoy that effect. And you can do... Unity will let you do health bars in like a zillion different ways, and I just think that one looks particularly cool. We can do a traditional health bar. Later on, as we move through this, we may decide that we need health bars for the zombies, so that the player can see that, why isn't that zombie going down? Because it's got a lot of hit points. And we'll talk about how we want to present that to the player. I like the round one because it's kind of a neat effect, and you don't have to do very much to get it to work. Okay, so the game looks pretty good. We do still have the bug where one of our walls is labeled as a zombie and it bleeds when you shoot it, but I'm pretty sure that you guys can figure out how to undo that if it's something that's really bothering you. But we actually have a bug in our code, I discovered, while I was working on one of the effects that we're going to work on this week. So, let's open up our zombie and go to the zombie AI simple script. Open that up in Visual Studio. Sometimes when you're programming, you will find that you can stare at a problem and know that something is wrong and not be able to see it. And then you sleep on it for a day or two, and then you have this moment of like, wait a second. So, if you will recall, a while back we moved this and not is attacking flag down into the if from this external if. What happens when we do that is that the zombie cannot attack if it is already attacking, which is correct. But the zombie can move if it's attacking, which we don't want. We want the zombie to stop in place when it's moving. So, I fixed this by... By moving this back up here, Control X, and then Control V. Okay. So what was happening is what this block says is, if I'm not dead, so my is dead flag is false, so not my health dot is dead, and I'm not disabled. So my disabled flag is false, and so not false is true. And I'm not attacking. Then update my destination, and then check to see if I'm in attack range and start attacking. But the is not disabled, is disabled is false, right? So what was happening is, when we were doing this, is disabled was false. So when it was failing out of this loop, it was coming down to this loop instead, which is not correct. So, yes. We're going to change it to say if is disabled. And we're going to have to come back to, I'm going to uncomment this out. So, basically what happens when the zombie dies, this block will stop processing. Because is dead is true, so not is dead is false, so this whole block gets blocked, which is correct. What we want to do is, when we're dead, have it run this check. So, we're going to change this from if is disabled to if my health dot is dead. So if my health that is dead, in other words, if that is true, then stop my agent and stop my nav mesh and disable my nav mesh agent. Now, the is disabled being true will make this block fail, but my health is dead will already make it fail, so there's no reason to have this in here. We can keep it for now, but I think I'm going to get rid of is disabled altogether because the only time a zombie should be disabled is when it's dead. So anyway, that should fix it. So let's save this code and let's go back over to Unity and maximize this. And I'm going to actually turn the music off for now, just because I'm having to kind of talk over it in my head. It's in my virtual cam. No, sorry, it's in my main camera. And audio source, I'm just going to disable the audio source. You can leave the audio listener on so I can hear the gunshots. Press play. So what I want to see is if I kill a zombie, does it move after me? Or if after a zombie is in the middle of attack and I move away, does it move after me? So he finished his attack and then started back up again, which is what we want. And if I kill a zombie, whoop. That's what we had the problem there. Okay. So yep. So then we had the chicken and egg problem of the nav mesh has to be disabled. Haha. Health. That is dead. And so we're going to take this line, this enabled line, cut it out and put it down in this block. So let's go through the logic here. If I'm not dead and I'm not disabled and I'm not attacking, then I can update my location and I can go in and attack and do stuff. If I'm dead and I haven't disabled already, then stop my nav mesh agent so that it keep me from moving, and then turn my disable flag on equal to true. Then the next frame, because update's called every frame, this check will fail because is disabled is now true, so not disabled is false. So this block will be skipped, and it will come down here and say, if I'm dead and I have been disabled, in other words, this block is finished, then disable my nav mesh agent. I'm pretty sure that's going to work, but let's go see. Oh, I got the stupid fallback. Sorry. This is just that display window problem. Maximize on play. Okay, so I'm going to shoot him, and he's dead, and he's not updating and chasing me, and I can run over him because his stuff is all disabled, and I can't shoot them when they're dead. So that looks like it's doing what we need it to do. Okay, so to reiterate what we did here, we put is attacking back up in the update, the primary if statement, to see if the player has the ability to, or the zombie has the ability to update its destination or to start attacking. And if any of those flags is true, then the statement will be false and it won't be able to move. I won't be able to move or attack. Then in our health, in our else clause, we switched out not is disabled and added in my health that is dead and not is disabled to first stop our nav mesh agent. Then, once it's disabled, then we will, once the is disabled flag is set true and we're dead, then it will, on the following frame, update the nav mesh agent to not be enabled anymore. Blah. Okay. So, did you guys get all that, or was I going too fast? Okay. If you need me to throw the code up in the chat window, let me know and I can do that. Anyway, so that looks pretty good. And then we can get started with our new features. We're going to do 2 new features tonight, for sure. And then I have a third one in my back pocket if we go pretty quickly. So the first one is we need to talk about dot products. So I'm going to open up a Wikipedia page here. Let me do this here. Okay, so I can get an image to show you what I'm looking at. Okay. I am utterly failing to find the image I was looking at last night. Okay, so let's drag this over here. I'm going to take a look at this webpage. So the dot product is a way of multiplying, using linear algebra to multiply two vectors together. And linear algebra here is not high school algebra. It is a separate field of mathematics. Linear algebra is largely used in video game graphics. And this is one example of what you would use it for. And programming. So remember that our vectors have a magnitude and a direction. And the dot product gives you a scalar value or a numeric value when you dot product them together, multiply them together using the dot product. The upshot of all of this is that if the two vectors are pointing in the same direction, the dot product is 1. If the two vectors are pointing directly away from each other, the dot product is -1. If the two vectors are at 90-degree angles to each other, the dot product is 0. Well, so what? Well, what we can do with that information is we can tell which way our player is moving relative to which way our player is facing. And the reason we would want to do that is because we want to where's my movement? We want the player to move slower when he's running backwards than he does when he's running forwards. So that if you're running away from zombies, you can get away from them, but if you turn around to shoot at them, you're going to be slowed down because you're walking backwards. Let's take a look at what that looks like. Okay, so this page will explain how dot products work, and you can see that it's a function of cosine, and if you remember from high school geometry, cosine starts at 1 and then cycles through at at 180 degrees, it's -1, and then it cycles back up to 1 again. So that's where we're getting that 1 and -1 from. So I'm going to hit close on this, and let's put that into action here. So we're going to go to our player, and basically we want to open up our movement script, because this is really a movement function. There's some argument that you should put it in animation, and we are going to mess with the animation too, but we really should put the movement controls in movement. So our movement function we haven't touched in forever. It's one of the first things we did. So let's open it up and take a look at what it does. So it gets our input, and it tells us which direction we're moving our movement keys, the horizontal and vertical, which are the WASD keys or the arrow keys on your keyboard. Right now, we're going to eventually port this to a gamepad, but and then it multiplies, it normalizes it, so it's clamped to a magnitude of 1, and then the movement speed is multiplied by the movement speed, so you can make the player run faster or slower depending on what you're doing, and then it sets it passes that vector onto the character controller in the dot move function down here at the bottom. Okay, and then it multiplies the vector move direction to create the new move vector multiplied by time.delta time, so that the movement speed is frame rate independent. That's what this whole thing is doing. This line right here, line 26. It's just saying, I want you to move so that if he's moving 8 meters per second, that's true no matter how fast the frames are being rendered. So that he's not moving a lot faster on fast machines or a lot slower on slow machines, because that doesn't make any sense. Okay, so what we want to do is we want to go get the direction that he's facing and then compare that through the dot product with the direction that he's actually moving. So, let me open up my reference here to make sure that I'm not telling you the wrong thing. Okay. Yep. Okay. Okay. So let's come down here under the clamp line. So at line 34, let's press enter a couple times so we can get some space to work in. And what we want to do is we want to create a new float called my relative direction. Sure, my relative direction. That's not the best name in the whole world because it's really my dot product value. But I'm going to call it my relative direction so we can kind of remember what it's supposed to be doing. And this is pretty straightforward. It's going to be vector3 dot, and dot is a built-in function in Unity. It works all this out for you. Actually, I think it's actually built into C#. Anyway, it takes the vector of two vectors. So we know one of them is my move direction. And then I need to figure out which way the guy is actually facing. And there's a couple ways we can do this. We can go out and get the component that is his aim controller and have that return his aim direction. But we're always facing the way we're aiming. So I can just do transform dot forward, which is delightful because, sorry, turn this sound off here. Sorry about that. So anyway, what this will do is it will spit out the dot product of the vectors. Let's just take a look at what that does in the console before we move on with actually adding the logic. Debug.log, my relative direction. Plus at plus time dot time. So what I'm doing here is I'm saying every frame I want you to tell me what the relative direction is at time dot time. Okay, so let's go to Unity. I'm going to uncheck maximize on play because I want to see the console. I'm going to go to Windows, General Console, or Control-Shift-C. I'm just going to drag it up behind the scene window because I don't need to have it covering the rest of my interface. So I'm going to press play. Oh, actually, you know what? Let me go here. I'm going to take out. What I did was I double clicked on the log. It said in-shot coroutine because I already know them. And we have a lot of debugs that we have in the game that we need to get rid of. So I'm going to go to the weapon handler, and on line 36, I'm going to comment out debug.log in-shot coroutine. We no longer need to know that information. We know that that's working correctly. So let's go to the next thing. Did hit. We know that's working correctly. So we no longer need this debug. I'm going to leave the draw array because I find it useful to be able to see the rays, and then we don't need to know what we hit because we already figured that out. We don't need to debug did not hit. I'm going to leave the missed draw array just so we know that it's there. Save it. And that's the line we commented out already. And should not be capturing when there's a hot control. I have no idea what that is. That's not a comment that we created. That's something that happened in Unity. Anyway, let's go ahead and clear these. And we're going to press play. And I'm going to start off by moving forward. Sorry, I'm moving to the left. I'm going to start off by moving forward. And you'll see it says 0.99657. There it's 1. You have to be moving exactly in the same direction as you're facing in order for it to be 1. If I start moving backwards, see it jumps to -1. And if I move north, or therefore laterally, it's -1.19209 -7. What that means is 0. That is a number that is very small. It's not exactly 0 because I'm not moving exactly 90 degrees relative to the vector that it's comparing it to. But this e to the negative... stop this. Go back up to where I have one. This number if you're not familiar with this notation, copy this here. And let me open up Notepad++, and I'll show you what this is. Duke. Come over here. Come over here. Okay. Come over here. There we go. Okay, so here's that number. This is what that number actually is. It is negative 1.19209 times 10 to the negative 7. Okay, so if you remember from algebra, maybe, this means move the decimal 7 spaces to the left. So it's negative 0.12345619209. That number is not actually 0, but for our purposes, it is as close to 0 as it's really close to 0, is what I'm saying. Okay, so that's what that is saying. When you're at moving at a right angle, no, don't save any of that. It's gonna be effectively 0. So what are we going to do with that? Well, there's 2 different ways we can approach this, and we're going to start doing it in a big sledgehammer way. Let's go back to the movement script. I have a bunch of scripts open that I don't need open anymore, so I'm going to close weapon handler and shot handler, and I'm going to leave zombie A simple because we're going to come back to it in a minute. Okay, so so we can say that if my relative direction is less than negative 0.5 f, then, sorry, you don't have to write the word then my movement speed is going to be times equals 0.25. No, because that'll do it every time. We only want to do it once. Let's do this instead. Let's create some new floats here. Let's create them under my movement speed, actually. Public float my backward speed. Backward and backwards. I don't know. And we're going to set that equal to 2. I can set it in here. I can also change it in the editor because I made it public. And public float my lateral speed is equal to 4.0. And then public float my forward speed is equal to 8.0 f. Okay. So if it's negative, then my movement speed needs to be set to my backward speed. There. If it's not negative, but it's still not quite forward, then else if my relative direction is greater than or equal to negative 0.5, and my relative direction is less than or equal to 0.5, so that means you're moving either to the left or to the right, then my movement speed should be equal to my lateral speed. Make sure I have the chat open. Yep. Okay. Okay, and then else. So if neither one of those conditions holds, then we're moving forward. So we want my movement speed to be equal to my forward speed. And then we have set in every case we're going to set my movement speed equal to one of our speeds, and then we're going to set my move direction to be equal to some flavor of that. Okay, so let's try this again. Save this, come back over here, spinny, build the code, and then go back to my player. And in the movement script, you can now see our speeds. And we're saying the default movement speed is 8, forward is 8, lateral is 4, backwards is 2. I'm going to maximize in place so you can see this. And press play. Okay. So when I move backwards now, I'm moving much slower. When I'm moving to the side, I'm moving a little slower. And moving forward, I'm moving a lot faster. So if I'm running away from zombies, I can get away from them fast. If I'm facing them and backing up, I'm not moving nearly as fast. And in fact, they're catching up to me, which is, die, zombies. So that's pretty good. And this is the way that the original game was designed. But then I was thinking about it and discovered, wait a minute, we could actually make it a really smooth transition rather than making it cut off at the angles of 45 degrees. By instead, and you can leave your code the way it is. I just want to demonstrate that method. I'm going to comment these out entirely and do public float my maximum movement speed. And I'm going to set this, my base movement speed, not maximum. Do my base movement speed. And I'm going to set this equal to 6. Do I want to do 6 or do I want to do... Yeah, 6 will work. Okay, so I'm going to comment these out. They have red squigglies because I commented out the variables that we're feeding into them. And instead of that, I'm going to say my movement speed is equal to my base movement speed plus my relative direction, my relative direction times 2.0 f. Okay, again, this is a magic number, and we're going to want to make it put it into a variable so that we can play with it. So basically what's going to happen is this. If my base movement speed is 6 and I'm moving forwards, then it's going to take my relative direction, which is 1, multiply that times 2, and give me a forward movement speed of 8, which is what it is now. If I'm moving to the side, it's going to take my base movement speed, which is 6, multiply that, or add to that my relative direction, which is 0, multiply times 2. 0 times 2 is 0, so my base movement speed is going to be 4, so I'm moving laterally 4. And if I'm moving backwards, it's going to subtract 2 because it'll be multiplying times -1. So we can save this, and here, and now you smoothly slow down as you pass through your arc relative to your forward direction, which I think is pretty cool. You want to play around with the values, because one of the things that I had in my original design was that the zombies will move faster than the player when he's moving backwards. So we can do that 2 different ways. I'm going to change my hierarchy to alphabetical. We can keep fiddling around with the player to find a better base speed, but I think 8 at your forward maximum movement speed is probably pretty good. And so instead, I'm going to make my zombies a little bit faster. So they are both moving right now at 3.5, and I'm going to make them move at 4.5. They also have an acceleration problem. Our zombies don't accelerate very quickly, and I'll demonstrate that. So let me let them get close to me and bite me, and then I'm going to run away from them and watch what happens. Come on, zombie. Dinner time. Okay. He bites me, and now I move away. And he takes a minute to get up to his transition there to speed. And part of that is his animator controller, right? Because if we go to his animator controller, Windows, animation, animator. I clicked the wrong button. Window, animation, animator. For our zombie. Remember, the animator is attached to the actual model, not to the container. So going from idle to run. No, it doesn't have. Yeah, for some reason this was expanded. It should be set to basically 0 because we set it to 0.1. Anyway, I took this. So what I did was grabbed this handle here and just shrunk this transition speed. Let's see if that helps a little. It probably won't, but let's look. Stop, and it helps a little. But a bigger problem is, back to my zombies. A bigger problem is that they are not getting up to their maximum speed very quickly. So I'm going to change this from 100 to 800. And I'm going to change their angular speed from 120 to 800 as well. And let's watch them and see what we get here. First of all, they're handling corners better because they didn't turn very quickly before. And also, they basically get immediately up to their maximum speed. So you can see that as soon as they start moving, they're moving faster than I am because their maximum speed now is 4.5, which is higher than my backwards moving speed of 4. Okay, so they'll eventually catch me. But actually, now that I look at it, I want to give them actually a backwards moving speed, a forward moving speed of 6. So the player will feel like he's at a real disadvantage if he's running backwards because the zombies will be much faster because you're moving backwards at 4. So they're catching up on me. That's more the feel that I want. And then I can turn around away from him, and I'm running faster than he is until I turn around to shoot them. When we have larger hordes of zombies, this mechanic is going to be a lot more apparent because you're going to be running away from them, get to a distance, turn around and shoot, then run away some more, and hope you don't get trapped in an alleyway. Okay, so that's the first effect I wanted to do, and I like that implementation. So I think I'm going to stick with that. Now we can also change how fast the player is actually animating. So let's grab our player. And remember, the animation is tied to the object. I said that before already. We've got our locomotion here. And remember that our speeds that feed into the game actually control this animator. I'm going to uncheck maximize on play and press, make sure I have my soldier selected, press play. And you'll see that as my vertical and horizontal movements change, I get different animations. So when we're walking backwards, we're playing a backwards walking animation, and when we're running forward, we're playing a running animation. But we can actually take make the animation run at different speeds. So let me come here. In the animator controller, we've always left this clock sitting at 1, and this is the animation speed. So when he's walking backwards, I want him to be visible to the player that you're moving really slowly. So I'm going to change the speed of the backwards walk to be 0.5. And when you're running forward, I want it to feel faster than when you're running to the side. So I'm going to make the animation speed equal to 5. Sorry, 5 is way too high. Make it 2. In fact, 1.5 will probably do it, but I'll make it 2 right now just to demonstrate the effect. Sorry, let me maximize my screen and hit play and then go. Okay, so when we're walking backwards, it now feels like we're walking very slowly. When we're going laterally, we're going a little faster. And when we're running forward, you can see that our legs are really pumping and we're moving faster. And that makes the character feel more like he's in a quagmire when he's running backwards, which is what we want. So I'm happy with that. You can play with those values, make them faster or slower as you want to. In fact, I'm probably going to make this... I like it at 2, actually. It's top down. You don't see it really well. So anyway, that's how easy it is to change that because we're already using the direction that we're moving to determine which of our angular runs we should be playing. We can manually play with the animations in this editor. We can also access these through code, but this is already a pretty solid solution, so I'm not going to get into that. One thing I do want to change here, while we're in testing, is the intensity of my overhead light. I dimmed down to 0.01, which makes the game very dark. So I'm going to turn it back up to 1. So it's still nighttime looking, but at least I can see a little bit. And you can make it different flavors of nighttime if you want to play around with it, or head more towards a daylight color. Just after a while, watching your character on a dark screen with a flashlight over and over can be a little tiring. That's just personal preference. You can change it back to whatever you want. Again, it's your game. You can do whatever you want to. Okay. So the second effect we want to do tonight, where am I on my time? Oh, gosh. That took a lot longer than I thought it was going to. The second effect we want to do here is we want to demonstrate to the player that the zombie is biting them. The way we're going to do this is with a sprite animation, and this is a little effect that I cooked up as part of the demonstration game that I built before we started doing this. So if you go to my sprite images, so go to Assets, My Effects, My Sprite Images, you'll see that there are 6 bite effects here. So I drag this up. It's a little hard to see because it's on a background of gray and white checker to indicate that it's transparent. But if you scrub through this, you'll see that you've got a set of teeth and they're biting. I don't know if you can see it or not, but you'll see it in the game in just a second. Anyway, so we want to put the animation into an object that will float above the zombie's head to indicate to the player that he's being bitten. And we're going to do that with some more animation events, and then we're going to do give the zombies attack a sound, which will also tie to an animation event. But first we need our animation. I already have it in here because I created it for this thing, but let me explain to you how I created it. So I'm just going to grab Shift and hold this down, and then I'm going to drag these 6 sprites that all have a name and are sequential into my scene. And then it knows that I'm trying to create an animation. I didn't have to click anything. It just pops this window up. I do bite, animation, 2. And click save. Okay. So if I go to bite animation 2 and grab the object that is pulled on the screen and press play, you'll see that it is playing an animation. Nifty. So I'm going to get this out of my screen because I actually don't want that object. Actually, no, we can actually leave this object. Yeah, let me press play. I'm pretty sure this will work. Maximize. Yeah, okay. So what this does is it creates an empty game object. It adds the sprite renderer, which we were going to do manually. It adds the animator, which I was going to do manually. And the only thing that we're going to change about it is what material it's using. So that's pretty great. I'm going to grab in my effects, my sprite images. There's a material called Byte Sprite Matte. So grab Byte 6 and let's rename this to Byte Indicator. And we're going to grab Byte Sprite Matte and drag it into the inspector here. And notice that my Byte sprite is now transparent, which is what I want. There's literally nothing to this material at all. It's just a sprite shader, and all you can change about it is the tint and the pixel snap if you need to snap pixels, but we're not concerned about that. We have the render queue, which shows where it is in the renderer, and we'll get into that when we start talking about shaders. Yep. But you can also make your bytes look red if you want to. Or you can make them look yellow or green or whatever. I'm leaving them as white for right now, but we may play with that. You can also change the transparency. Right now it's set to 71. So you can make them solid or completely invisible. If you make it completely invisible, the player wouldn't be able to see it. Set to 71. I like making it transparent because it's going to be over the zombie's head and it's going to be kind of covering up the action. We want it to cover up the action because we want the player to know something terrible is happening, and it's going to actually appear right over the player. So let me get my reference script up here. Give me 1 second to get myself set up here. Okay. Can I see everything? I think I can. Okay. So but the thing is that by default, this object is rotated so it's facing a normal world's forward direction. And I actually want it to be facing straight up. So if I click on Y, you see that if I make it orthographic, it's invisible from the top. But we're doing a top-down game, and we don't want it to be invisible, obviously. So what I'm going to do is right next to it, I'm going to do right-click and I'm going to go to Game Object, Create Empty. And it will create a new game object in the world. And I'll move it over here. And I'm going to move it around in 3D space so you can see what I'm doing. And then I'm going to rename this object Byte Holder, because it's actually holding the byte indicator. And then I'm going to take byte indicator in my hierarchy and just drag it so that I have byte holder highlighted and drop it onto it. So now the byte indicator is now a child of the byte holder, but the byte indicator is here and the byte holder is over here. And I want them to be in the same place. To do that, I'm going to take the byte indicator's transform and set it to 0, 0, 0, because remember the transform is relative to its parent. So if I go to my byte holder and byte indicator, and I can switch back and forth between them, and you can see they're both in exactly the same place because that's what the transform says to do. Okay, but I don't want it to just contain it and have it be in the same orientation, because then there's no point in creating the holder. What I want to do is I want to rotate this thing 90 degrees on the x-axis, and I believe I also want to turn it around, but we'll come back to that. So now if I press, I'm going to switch to my orthographic view. So I'm looking from the top down. Sorry. And I press play. Then I got my byte happening, and everything looks good. It's not where it's supposed to be yet, but we have it. So let's go into my effects, and we're going to drag the byte holder into my effects. That will create a prefab, and when we have a prefab, we can do all kinds of cool stuff with it. One of the things we can do with it, let's go to byte holder, and we're going to change its tag from untagged to, I'm going to add a tag here called byte indicator. And I'm going to go here, and I'm going to change the byte holder's tag to byte indicator. The reason I'm tagging the external object and not the child, the child that's still with us is untagged, has to do with how our object pooler works, as you'll see in just a second. Okay, so now I've got this. It's set up exactly the way I want it, so I can go ahead and delete it out of the scene. Actually, sorry, before I delete it, in the overrides, you see that I've got an override in byte holder because I changed the tag. So it says, this is the thing that's going to be changed. Byte holder, you change something in the byte holder. And I'm going to click apply all. So it will apply it to all the prefabs that exist in the game called byte holder, ones that are in the scenes and ones that are in the project folder. And so now I can delete it safely. If I look at byte holder, you'll see that it's got the correct tag. And it's facing upwards. Everything is great. Okay, so now we just need to spawn it. So, but if I'm going to spawn something over and over in a game, because I want what I want to have happen, I want it to come alive, bite once, and then go away. So if I'm going to spawn something in the game over and over, it means I probably want to use my object pooler. So, and that's exactly what we're going to do. We're just going to go to items to pool, change this number from 2 to 3, and we're going to change this from effect wall impact to just drag your byte holder into the object to pool. And we certainly don't need 20 of them. Let's pool 5 of them, but let's leave should expand on, because if a zombie bites, we want the object to be spawned, even if the pool has been used up. In fact, yeah, I'm happy with both those numbers actually. Okay, so let's go to here. Okay, so if you go to, this is an animation, so we're going to have it handled by our zombie animation handler. So let's go to zombie animation handler, and we're going to create a couple of events, a couple of functions. First one is going to be called byte indicator start. Public void byte indicator here start. Okay, and first thing it's going to say is if my byte indicator is null. You have to use double equals here because you're saying if this thing is equal to this other thing. But my byte indicator does not exist. So let's go up to the top of the script and add a public game object called my byte indicator. Now we're not going to set this to anything. We're going to leave it equal to null because at the beginning of the game, the zombie shouldn't be biting anything. So anyway, so byte indicator start. So we're going to say, first, go and get the next one that's not being used from our pool of objects. And remember that the syntax for this is a little funky. It's object pooler dot shared instance, which is the name of our shared instance. And I really should fix that because it's confusing. But get pooled object pooled pool object. And remember that this requires a tag, and we're going to get byte indicator. Why are you complaining? Get pooled. I must have had a typo in there. Okay. So this says if I'm told to start my byte indicator, then go and get one of the byte indicators from our pool. Then I want you to put it where I'm standing. Sorry. Then I want you to parent me to the zombie. So this says, go get my object and actually parent it to the zombie. We didn't do this in for the walls because it doesn't really matter. But I kind of want if something happens and the zombie ends up moving around at all, I want the byte indicator to move along with the zombie. Right now our zombies are just stop while they're biting, but we may have bitey zombies that can keep moving, and I don't want to have to refactor this when we do that. So this just says make it a child of my zombie. Then now set to where I'm standing. So my byte indicator dot transform dot local position is equal to new vector 3 0.0f 3.0f 1.8f. So what does that do? Let me go back over to Unity for a second. Remember that when we made, we said that if an object is a child of its object, the position values are local to the parent. So if I set this cube at 0, 0, 0, the soldier is at 0, negative 1 because the actual capsule that's holding the player is up in the air. They're relative. But if we instead of using local position here, if we just use transform.position, it would assume that we meant in world space, and we don't want to set it in world space. Normally when you're setting positions, you use world space, and they don't want to make you have a special carve out for that every time you do that, because normally you do. So they make you have a special carve out for if you mean local position, which is what you see in the inspector. So what this does, it says make the zombie my parent, and then set my local position, these relative values here, set the x to be 0, the y to be 3, and the z to be 1.8. If you set something to those values, it's going to be 3 meters in the air, because y is going to be 3, and 1.8 meters forward. So it's going to be 1.8 meters in front of the zombie. I worked on these values for a little while yesterday to try and make sure that I could that they looked okay, and they will. But you can play around with them and make them perform however you want. I want the byte to be more or less centered over the player, but also sort of offset in the direction of the zombie. The zombie's attack range is 2.5 meters, I think, right now. So setting it off by 1.8 moves the thing mostly over the player, so the player can see that he's getting bitten. Anyway, then we're going to my byte indicator dot transform dot rotation is equal to my transform dot rotation. So set it the rotation of the bitey bit to face the same way that my zombie is facing. And remember that the byte handler is oriented the same way that the zombie is, where forward, the z direction is forward. So the byte holder is oriented like a regular object, so the z direction is forward. So that we can do this without having to futz around with trying to compensate for which direction the object is facing. Again, we're doing magic numbers in here. We shouldn't do that. We should actually create a vector 3 and have and be able to set it and change it in the editor. But for right now, let's leave it as it is. And then we're going to do my byte indicator set.setActive true. Remember that when objects in our pool, they are disabled, right? And it's get pooled object says go get the next one that is disabled and use that one. It's going to go get it, set the parent to be the zombie, move it to the zombie's location, put it 3 meters in the air, 1.8 meters forward, rotate it so it's facing the same way the zombie's facing, and then turn it on, which is exactly the order of events that I want. And that's everything we need to do for that function. And the reason that we check to see if the byte indicator is happening is because if you don't do this, it generates a new byte indicator every frame. So I ended up with a lot of byte indicators. So I almost wanted to show you that, but it's just so confusing about what was happening that I decided just do it correctly the first time. Sometimes it is helpful to watch me fumble around because that's how programming actually works. But I spent a couple hours on this yesterday, and you don't want to watch that. Okay, so then we have another function called my byte indicator end, which says my byte indicator dot set active false. My byte indicator dot transform dot parent is equal to null, and my byte indicator is equal to null. So let's look at what this is doing. The byte indicator set active is equal to false, so it returns it back to the inactive state, which means it's now eligible to be picked up by our pooled object in our object pooler, as a pooled object in our object pooler. But it's still parented to the zombie, which is not what we want. We don't want it to somehow grab the zombie and move it around. So I went ahead and explicitly said, hey, my parent is nothing. So it's just sitting in the world wherever it ended, and will be available for our object pooler to go grab next time. And remember, the first thing our object pooler does is move it. So it doesn't matter where it ends up. And then my byte indicator is set to null. Remember that my byte indicator indicates that we have a byte indicator that we're already working with. And if it is null, then it goes through this process if it gets the indication to start byte indicator. Cool. Okay, so that's all good. Let's save all that. And nothing's going to happen yet because these are just functions, right? Nothing in the game is calling my byte indicator start or my byte indicator end at this point, but we're going to change that in just a second. So let's go back to Unity and let it compile that. And then let's go to animation aggressive byte control 6. Yep, that's exactly what we want. Okay. So let's go here. Okay. Let's go to our folder that has our animation in it. Remember, that's in Toon Zombies Extended, Animation, Aggressive Byte AE. Oh, wait, we have to deal with the animation effects, which I forgot about. Sorry. We'll come back to this in just a second. Remember that our zombie has a script attached to him called Zombie Animation Event Handler. So if we go here, we go to Zombie. We've got a zombie animation event handler. Remember that the animation events can only apply to the model that the object is attached to, or that the animation is attached to. So it can't, we can't quickly and easily access functions in the parent container. So we created this little animation event handler to say, hey, if you get an animation event, then I know what to do with it. So let's open up Zombie Animation Event Handler. Okay, and this is pretty straightforward. Remember that right now all it does is say, if I get the animation event of zombie attack succeeded, then go to my zombie AI simple and tell me that the zombie attack succeeded. And then when the byte attack ends, tell me that the byte attack has ended, because that, remember, turns off our animation and tells our is attacking flag sets back to false. So we're going to add a couple of quick functions in here. So we're going to add public void byte indicator start AE. And that AE, remember, just tells us this is animation event handler. And we're going to transform dot get component and parent. Animator handler zombie dot byte indicator start, and there's no arguments. So this says, for my transform, the zombie model transform, get the component and parent, which is the containing object, my animator handler zombie, and then call the function byte indicator start, which remember says go do all this stuff. And then, unsurprisingly, public void byte indicator. Oh, I said byte indicator. It should be byte indicator start. Byte indicator end AE transform. I can actually just copy this line because I'm going to change one word and change this from start to end. Okay, so we're going to save that. So now our zombie animation event handler will call byte indicator start and end whenever we tell it to. Okay, so let's go back to Unity. Now we need to create some animation events, and we had a little bit of a tricky time last time, and I'm still not quite sure what the order of operations is supposed to be for this. So we may fumble around a bit here, but we'll get it working because I got it working last night. So let's turn on our demonstration zombie. Remember, he's turned off normally because he doesn't have any of the other zombie stuff, and so he causes a bunch of scripts to break. I can turn him on and press play, and the game will crash out immediately because the zombie event handler is trying to deal with stuff that doesn't exist. So he won't work while the game is running. So we're going to disable him when the game is running, but right now we need him because we want to look at animations. So we're going to go to his animation. So we're going to go to Tune Zombies Extended, Animation, Aggressive byte AE. And we're going to hit Control 6, which will take us to the animation window. And notice we've already got a couple of functions in here. One of them is zombie attack succeeded and zombie byte attack end. So let's grab our zombie and let's start scrubbing through this. Remember, it moves it into 0, 0, which is why I have my camera down here. Let's turn the lighting effects off in the scene editor by clicking on this button right here. Okay, so if we scrub through our scene, we said that the byte should happen right there. And that's when the effect happens. And then he's going to be considered still attacking while he's recovering. And this gives, you don't want the player to attack in the, to be attacked relentlessly. You don't want to have rapid fire attacks that the player doesn't have a chance to breathe from. You need to attack and then a pause so the player can take damage, know the damage has been taken, and then respond to it. Later on, we'll introduce some more bitey zombies that will do like a triple attack. But right now, we're going to just do a single bite. So we want the bite attack animation to start. So we can add a function in, and I piddled around with where exactly to set this. So let me open up my example in my other screen here. Shows me where the actual put these things. Control 6. Okay. Yeah, that's what I thought. Okay, so let me maximize this. Okay. So if we maximize this and go to the second frame, so we'll drag it back here. If I click this add event, that is the perfect place to add in the event for the byte attack to start. I'm going to minimize this. And you see in my animation event window in the inspector, it says you don't have a function selected yet. So I'm going to grab byte indicator start AE. Then I'm going to scrub over here to right where the marker is next to the 25-second indicator, or a quarter of a second indicator. This is in seconds, right? So so why is it compressed to 1? I'm not sure what our scale is doing something really weird here, but anyway, go to where it says 0.0:25 and grab that frame. And we're going to click add event, minimize this, or not shrink it, not minimize it, but shrink it. And you'll see that I have an event, but I haven't selected the function, and I'll do byte attack end animation event. Okay, close this. I'm going to click my byte. I'm going to hit Control 6 just to make sure all my functions are there, and I can see that they are. If I click on this function, you'll see it's byte indicator start. My attack was successful. Sorry. Yeah, my attack was successful. bite should end. In other words, stop the sprite animation, and then the attack ends. Okay. So there's quite a lot going on there, and we've done a lot of little changes since we actually played the game. So let's take our demonstration zombie and let's uncheck him to make sure that he's not running, because he'll cause the game to break. And press play, and let's see what this effect looks like in the game. Zombie goes to bite me, and chomp, 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 chomp. So something weird is happening because the chompers aren't going away. So if I run away, they should go. They should go. Oh, wrong keyboard. Yeah, so they're continuing to attack, and they're never getting that bite attack in. So I think I set the event up wrong. Let's go to look at this by hitting Control 6. This should be bite attack end. That's the function. Bite indicator end. And press F12 here. Bite indicator end. So I'm messing something up somewhere. Do. Did I do bite attack end or bite indicator end? Bite indicator end? That's correct. Okay, so also in the zombie AI simple here, we've got our zombie attack succeeded. But for some reason it's not stopping. Look at my thing. Hit Control 6. This is bite indicate. I gave it the wrong function. That's why. Sorry, it's not bite attack end AE. That's the problem. I'm going to delete this function. Animation event, rather. I'm going to add an animation event. I'm going to take my demonstration zombie because I seem to have him selected when I'm doing this. Control 6. Come back to that same spot and add animation event and select bite indicator end. Okay. That's what happens when you go too fast. Oh, I pressed play and I still have my demonstration zombie in the game. Uncheck him. So yeah, you have to have the model actually playing the animation selected. So now when they bite me, bite, and then it turns off, which is correct. And bite, and it turns off. Yay. The problem is, as you can tell, I want the bite to actually be facing the other way. It's not a huge problem. So what we'll do to fix that is we'll go up to my effects. We're going to grab the bite holder and drag it into the scene. I can move the bite holder just up vertically so it's not intersecting with the terrain. And I'm going to go down to the bite indicator, and I'm going to flip it around 180 degrees. Go back to bite holder, click on overrides, and this is saying update my effect everywhere. And it says you changed the transform of the bite indicator. Did you mean to do that? Yes. I'm going to hit apply all, and then I'm going to delete this object. And then if I drag one into the scene and go down to its child, we can see that it is spun around correctly. So I can just get rid of that. Now when we play, let's play this. There we go. Okay. Zombie comes to get me. Zombie bites me, and I take damage. Cool. The problem is that, let's say the zombie bites me. I can get away, but the bite still hits. I can run away, rather, but the bite is still going to hit me. There we go. I'm clearly out of their range, but the bite still causes damage to me. So what we want to do is we want to change up what zombie attack succeeded does, and we want to check to make sure that the player is still relatively close to where the zombie actually is. We don't want to limit it to only being in range, because then if you take one step away from them, they can't move forward to catch up with you because they're not allowed to move when they're attacking, and taking one step backwards makes you invulnerable, which isn't quite right. We want the player to feel like the zombies are getting them. So, let's go to our zombie and grab zombie AI simple. And the zombie attack succeeded logic right now, it says whenever I get this function, remember that function comes from an animation event. It's called from an animation event. Whenever I get that, then cause damage to the player. What we're going to do is we're going to say, hey, is the player really still very close? And we're going to use the same methodology we used before. We're going to use the square difference because that is a little faster for the square magnitudes, because it's faster for the computer to calculate by a lot. So go vector 3, my difference vector is equal to my target dot transform dot position. Remember, that's the location of the player because the target is always the player. Minus transform dot position. And then we're going to create a float called my squared magnitude is equal to my difference vector dot square magnitude. And then if my square magnitude is less than or equal to my attack range times my attack range. Remember, we have to square it because we're comparing squared values. Times just a flat 3. And that's a magic number. The reason I'm including it is because I want to say, if you're relatively close to where you were when remember the zombie can't start attacking by our logic, can't start attacking until they're close enough to attack you. So, did you run away enough to not get damaged, have damage taken? And also, I want to choose one other thing, which is up here in our logic where it says do attack stuff. One of the things that I want to do is I want the zombie to turn and specifically look at the player. So I'm going to do transform dot look at my target dot transform. This says make this object rotate so that until it's looking directly at whatever its target is. So at the beginning of his attack, he'll look directly at you. He's not going to turn to follow you as the attack continues. But we don't want to have it up in the higher block, because then the zombies will always just stare creepily at your player, even if they're on the other side of the wall. But what I want to do is call this once when the attack begins, and then not again until the zombie goes to attack again. So we'll click save for all of that, and this should look a little bit nicer. So the zombie looks at me, and then if I get really close to them, watch this. You can see that their attacks will start to overlap, which is what we want. Die, zombies. So good. So all that's working as expected. I got one more thing we want to do for the zombies, and that is we want when the bite actually hits, we want to play a sound. So we're going to go to the zombie, and we're going to do add component. Actually, we need to do this for both zombies. So we're going to do add component, audio source, and we're not going to do a clip. We're going to uncheck play on awake. We're going to make sure everything else is unchecked because we don't want this to play while until and when the bite happens. And we're going to go into remember the successful attack logic is actually in the zombie AI simple. So I'm going to double click that, and I'm going to add a public audio source, my audio source, public audio clip, my byte clip. Throughout this process, I've been deliberately having attacks and bytes specifically used in different places because later we're going to use different sound effects for different kinds of attacks. But in general, the attacks logic should be the same. Right now, they can only byte. We're going to expand on that in the coming weeks. If you want to keep doing this, which, we're going to talk about in a second. Okay, so we don't want the sound to happen unless the player is actually hit. So we're going to come down here and say, if all this happens and the player is actually hit, then my audio source dot play one shot, my byte clip. And later on, what we'll do is we'll say, if you're using a byte, then play your byte clip, and if you're using something else, then play another clip, and we're going to talk about all that later. Okay, so it should play one from my byte clip. Yeah. Get component. Oh, we also need to set the audio source at the beginning. My audio source is equal to get component audio source. This is one of the reasons we don't start development with 35 zombies. It's just easier to handle when you only have 2 to deal with. Double click here. Let me think this through. Is that everything? Oh, nope, we need to assign the clip. So if you go to my sound effects, I think there's a bunch of things called Gore. This is from a huge kit called Universal Sound Effects that I use all the time. So let's grab a sound effect in here. If you want to just listen to these, they're creepy and weird. And I understand that over Discord you guys can't hear my screen, but in the video you can hear what the stuff my screen does. So I'm going to play a couple of these real quick after I find which one I want to use somewhere in the world. Well, let's just look at it. So let's try splat hit bubbles. Yeah, that's pretty gross. Let's use splat hit bubbles. So I'm going to go to zombie, make sure I have both of them selected. I'm going to grab splat hit bubbles mono, and I'm going to put it in the my byte clip. Gore splat hit bubbles is going to be my byte clip. Okay, so now let's hit play. So the first thing is I want to see if the sound effect plays correctly, so I'm going to let them bite me. It does. I'm going to run away, and I'll let them bite me. And you see the sound effect doesn't play. Okay, Tony, that's cool. See, the sound effect doesn't play because even though the bite effect started, I was able to get out of the range so the bite doesn't hit me. But when it does hit me, I can tell, and it's gross and disgusting. This clip is actually has got a little bit of a lag at the beginning of it. Let me look and see some other ones. You can see this gap right here means there's a slight pause before the hit actually happens. And we want the hit to happen the same time our hit points go down. So let me find one that's got a little bit more of a immediate. What I usually do in this situation is I go into a program called Audacity and trim the clip down. Let's try this. That's a little too gross. Yeah. Yeah. Okay, so let me try this again. Yeah, Gore Stab Splat Only Bubbles is probably pretty good too. Gore Stab Splat Only Bubbles mono. Put that in here, and that's a little bit closer to playing immediately on the beginning of the clip. And let's see. Yeah. You can. So we can remember that the audio clip is being triggered inside here after it's done all the logic to make sure that the byte actually hits. So what we really want to do is actually back it up, start the audio clip a little bit earlier than when it hits. If we delay it, it's going to be more offset. It's playing a little bit. It's lagging a little bit. So let me see if I have Audacity here. I can just show you how to do this. I do, because I use it all the time. So Audacity is a third app. It's free. And you can take a clip and drag it in here, and you can cut it up. So I'm going to go to, let me grab my file here, and let me go to my game dev folder. Let me grab 9 assets. Sorry, I'm almost done, guys. Bear with me. My sound effects. I'm going to grab Gore Splat Hit Bubbles, which is the one that I like. I like this one better, but it didn't do what I wanted to do. No Audacity over here. Okay, and I'm going to grab Gore Splat Hit Bubbles. Okay, and then I'm going to go here. And you've got a bunch of functions here, but by default it selects the selection tool. And I'm going to grab the selection tool and just put it right there. And then I'm going to grab all this stuff in here. Stop doing that. Stop. I'm going to go here. And I'm going to grab the cut. Yes. And I'm going to click cut. There. So now when we press play, you can't hear it for some reason. Why can't I hear it? That's weird. But it basically is going to get rid of that pause. So I'm going to do File, Export as Wave, just so it's in the same format that all of my other ones are. And I'm going to call it Gore Splat Hit Bubbles Mono Trimmed. And I'm going to click Save. And I'm going to go back to my game. And where is it? Gore Splat Hit Mono. Dang it. What happened? File. Oh, sorry. I had another window I needed to deal with, which is this. Because it's used for creating sound effects or music tracks, you can use Audacity for music tracks, which is what most people use it for. And you can see I got it from Universal Sound Effects. It does stuff like tell me the album name, which we don't care about. So we're just going to click OK. Now it'll be in our game. It should be in our game. File, export as wave to, let me go up here. That was in the wrong. This is the problem when you have 8,000 games in the works. I saved it to the wrong game. So now in my island adventure, I've got a Gore Splat Hit Bubbles Mono Trimmed. Let's go to 9. Let's go here. It'd be really, it'd be gross. Trimmed, save. Now I'm saving it in the correct format, in the correct project. And now, oh my God. Did I save it the wrong level? No. You can tell I'm getting tired at the end of a long day when I can't seem to save a file correctly. File, export. I saved it in the game dev folder, not. Oh my God. Let's do this. Save. Okay. Try it again. My sound effects. There it is. Finally. Okay. Grab my zombies and drag this trim thing over into there. And yep. Now we should do this. And now the bite sound should happen exactly when they bite me, which should coincide with the teeth closing. Yeah. And they can start to bite me, but if I get away, the sound doesn't play. Yay. And I can tell they're trying to bite me. Okay. So, to recap what we did tonight, we added in the last effect, which is the bite effect for the zombies. We allowed the player to move faster when they're moving forward and slower when they're moving laterally or advancing to the rear. And that's, and we added the sound effect for the zombies' bite attack. We can do things like change the pitch of the bite attack, which we might want to do. We can have it be random so it's not the same sound effect over and over, which we'll probably do next time. And we need to talk about what happens when the player dies. But what I wanted to say was, this is the last session that covers the introductory game, the prototype game that I worked out at the beginning. I set out a series of design requirements that I needed to hit to get to this point. So this is our 9th session, but we now have a full game. You could take this basic game and add a bunch of other stuff to it. Make it your own. Put more zombies in, or use buildings instead of white walls as obstacles. And just taking what we've done up to this point, you can make a pretty solid top-down 3D twin stick shooter. I've asked you guys before if you wanted to keep doing this, and everybody keeps saying yes for some reason, which is cool. So we'll get together next week and we'll talk about some more stuff. Let me go ahead and stop the recording here. Stop there.